The U.S. penny was originally minted entirely of copper. However, after the year 1857, the U.S. penny was made of a variety of materials because of the high cost of copper. Since 1982, pennies have been made of zinc plated with a thin layer of copper. The modern-day penny weighs 2.500 grams, has a diameter of 19.05 millimeters, and an average thickness of 1.224 millimeters. Given that the density of copper and zinc are 8.96 grams per cubic centimeter and 7.13 grams per cubic centimeter, determine the percentage by mass of copper in a modern-day penny. What are we studying in this problem? Exactly, we're studying one modern-day penny. But before we dive into the calculations, let's take a step back and see how we should start thinking about this problem. The penny is made from two different metals, copper and zinc. Since we know the densities of copper and zinc, when we find the overall density of the modern-day penny, we can think of this penny's density as a weighted average of the densities of copper and zinc. This means the overall density is equal to the percentage of copper times the density of copper plus the percentage of zinc times the density of zinc. Now, let's take a closer look at this modern-day penny. To find the density of the modern-day penny, what can we do with this information? We have the mass, which is 2.500 grams. However, we have additional pieces like the diameter and thickness. A penny is a cylinder, just a little more flattened. How do we find the volume of a penny? Yes, the volume of a penny follows the formula for a cylinder, which is volume equals pi times radius squared times height. In this case, it is important to remember that half of the diameter is the radius, so the volume can be found by substituting r and h. What is the volume of our penny in cubic centimeters? Exactly. To get a solution in cubic centimeters, let's first change the radius and thickness to centimeters. Recall that 1 centimeter is 10 millimeters, so after finding the radius, 9.525 millimeters divided by 10 will give 0.9525 centimeters. The same for the thickness, turning 1.244 millimeters to 0.1244 centimeters. So altogether, what is the overall density of the penny? That's right. The density is mass, 2.500 grams, divided by the volume to give units of grams divided by cubic centimeter, which is 7.17 grams per cubic centimeter. Now we are left with two other densities in grams per cubic centimeter, so they can be compared. If the penny was made completely of copper, it would have a density of 8.96 grams per cubic centimeter. If the penny was made of pure zinc, it would have a density of 7.13 grams per cubic centimeter. However, our density is 7.16 grams per centimeter cubed. What does this mean? This density of the modern penny is closer to the density of zinc, meaning that there is a lot more zinc than copper. We do not know how much of each is mixed in exactly, but we do know that the total density is 7.17 grams per cubic centimeter. Using this information, we can create the equation. 7.17 grams per cubic centimeter times 100% of the penny equals to 8.96 grams per cubic centimeter times the percent of copper in the penny plus 7.13 grams per cubic centimeter times the percent zinc in the penny. What does the percent copper in the penny plus the percent zinc in the penny equal to? Yes, both metal percentages make up the entire 100% of the penny. Let's look back at the problem. We want to find the percentage by mass of copper, so we can rewrite this equation as 100% minus the percent copper in the penny equals to the percent zinc in the penny, and substitute the percent zinc in the penny in the first equation. This is getting a bit complicated, so let's replace all the percent copper with the letter C. When this equation is solved, what is the percent copper in the penny? That's it. Through the distributive property and then adding like terms, we get an answer of 1.91%. A few key ideas to remember is 1. It really helps to draw a picture for a problem so that we can see the thing that we are learning about and trying to figure out. 2. To simplify objects like pennies into geometric shapes. Chemistry does not get rid of any previous volume formulas and math we have learned before. 3. To utilize the concept of density to determine the overall density of a composite object. Compare this density to the known densities of the materials involved to understand the proportion of each material. Make sense of the numbers with logic.